In this video, we are going to discuss about modeling and predicting human behavioral patterns. So here is the theoretical model of my algorithm, and I'm going to show how it works exactly. These are the set of features you can see: triangle, circle, square, and right angle triangle and rectangle. So what I thought was I'm going to classify a human behavior based on 5 classes. So either she could be angry, she could be working, or she could be uninterested to talk, or she could be waiting, or she could be sleeping, or she might be feeling to sleep. So I've considered these data points. You can call them as data points or features. And these data points are not restricted to stay on the line or stay in between two lines. The data features can be belonging to, they can belong to other side as well, so it is not a deal. And using support vector machine, we can classify it as simple as possible. So I've used support vector machine. As you know, it is a classification algorithm. So let me show you the workflow of this. Let us discuss about the theoretical model of support vector machine. So this is how the support vector machine works. Here x1 is the feature and x2 is another feature, or x3 and up to xn. They are the set of features. So what we are trying to do is we are passing these features to the functions, and these functions compare the set of features, and a weight is associated to each of them. And here we pass in the input. As we pass in the input, the set of features are classified to the parent nodes, like angry or uninterested or working or anything else. So this is the workflow, how the model works. Our input features are passed into the SVM. Then from that, SVM matches those input features, each and every input feature, with the class features. Class features in sense the dataset features. So these are the dataset features, which are also known as dataset points or data points. These input features are matched or compared with those parent features of class, and the weight of the class is increased. I'll make it simple. Triangle belongs to anger class, and triangle might also belong to, it is near to this, so it might also belong to uninterested class as well. So maybe if she's angry, she's not going to talk to you, and she's uninterested to talk to you. So this is how the classification is done here. And as the data point is near to this, we can even conclude that maybe she's uninterested. So now what we are doing is we are incrementing the class weight by 1. So every time if the feature is matched, we would increment the class weight by 1. I'll give a real life example of this. This is the data set that I've considered, and this is just a partial data set. I'm not going to show you the whole data set. Okay, so I've classified their behavior to 5 classes: angry, working, uninterested, waiting, or sleepy. Now let the sample input be okay, else, ha, and seen. What I'm going to do is, according to human, if this data is given to me, and if I am if I was to predict their behavior, so I might be wrong several times, right? But a machine will be correct. So that's why I do rely on machines, and I build my code. Okay, so talking about the first feature, OK belongs to anger class and uninterested class. But though OK belongs to anger class, I can't just simply declare that okay, that person is angry. They might be uninterested to talk also, and it has to be and it depends on the other features as well. So we have to consider all the features of the input, and we have to match. Then according to the analysis, we have to take the most weight, or the class associated with most weight, and we have to conclude the input features input features belong to that particular class. So what I am exactly doing is I am just concluding that the person is angry, or the person is waiting, or the person is sleepy according to their chat responses. And see, so that's the reason I've incremented the class of anger by 1 and the class weight of uninterested by 1. The second feature, this the belongs to anger class, only anger class. So what I'm doing is only incrementing the class weight of anger. Third feature, else belong to anger. See, else belong to anger class, working class, and uninterested class. So I'm again incrementing all the classes by 1. And ha, see, you can see it from the data set. Ha belongs to anger class, and ha doesn't belong to any other class. So I'm incrementing the weight of anger class, and then scene. See, you can see here scene belongs to working class, and scene also belongs to sleepy class. So I've incremented their classes weight also. At last, when all the input features are done, what I have to do is compare the weight of each and every class. That is what I've done here. See, here the anger class wins because the weight of anger class is 4. So I can simply say that if the chat responses are okay, else, ha, and seen, if the message is seen or not replied, or I can easily say that that person is angry because here the anger class wins. So this is how I've classified the behavior according to the chat responses. I hope you like this, and please do share this video with all your friends and family if you're interested. And I'm going to implement this code in the next video.